for reference, we said it basically means a different name, right? For this program, in the past, we say when we declare a variable called int num, in a bunch of memory, it will create some space for you. This one is maybe 4 bytes, right? The size is 4 bytes, and this guy is enough for an integer. There are some locations in your memory, and your compiler will remember this guy is a num. And what does the second line mean is we are defining a new variable. It is reference to an integer, and it's pointing to exactly the same location as num. So it is a ref num. They are indeed pointing to the same part of location. So it means whenever you change either of them, you change num or you change ref num, because they are pointing to the same place, this is the place it's storing the data, right? Either 11 or 10 or 1. So whenever you change the value here, because they are pointing to the same place, whenever you change, the data will be changed in using another name, right? If you change num, you will also change ref num. If you change ref num, you also change num. So that's the benefit of reference. You could also play with that. So we said we could pass by reference instead of pass by values. So we say pass by values means copying all the data. If it's a vector, right? If it's a vector of 10, you're copying 10 elements. If all of them are double, you're copying 10 doubles. But if you are using a reference, we said it's just creating a new name that's still pointing to the same location with whoever is calling this function, they are still pointing to the same location. So for this one, and also inside your code, you are allowed to modify the v. Whenever you modify v, whoever is calling this function, their data will also be changed. So sometimes you will concern, will the data changed in here, right? For example, if it's a vector, and how about we implement a print function, right? We implement a print function, and we said implementing a print function is quite easy. It's just do that. Let's print out, iterate through all the elements. I less than cell the size plus I. I want to see out the cell of I, then separate by a tab, then see out a new line. Right? What we can do is separate them by a tab key and print a new line. This is one way. In this way, you are copying all these elements, right? There are 6 int, so you copy 6 int in cell. It's a new variable. And even if you change it here, the salary doesn't change. Let's run it again. If we run it again, wait, let me. Because it's copied, right? You only change the local variable cell, not changing the salaries. So when you print again, it will not change. But if it's a reference, when you run it again, the second time the first element becomes 0. That is because it's a reference. Cell and a salary, they pointing to the same place. And whenever you change cell, you also change salary. So the second time you print, it will print a 0 here, right? So in most cases, when we ask someone to print, we are not expecting them to modify your data. So what you can do is you put a constant here, making sure nobody could modify anything inside a cell. So when you put a constant here, as you can see, this assignment will becomes an error. You cannot assign value to a constant number, right? So in this way, you are making sure no one can modify your data, because most likely these kind of functions are written by others. You want to trust others, you just look at their head, right? What about their interface? The interface says they are accepting your input, accepting your parameters, but accepting it as a const. So they will not change your data. So you can trust them, right? So this is the way we can use a constant reference. So your concern is other people might change your data. So you could use a const so that to avoid others to modify it. This constant reference will be frequently used. So we say reference is very efficient because it's not copying data. It's just creating a new name pointing to the same location. So when you do a function call, it's basically have no overhead, right? And passing it by a constant reference, we can making sure the functions cannot change our data by accident or by intentionally anything. They cannot change it. And sometimes, right, passing by reference is not needed for small numbers like int, double. You most likely just copy them. It's fine. But for large ones, vectors, right, objects, most likely we are using a reference because that will save space and making your program runs faster. In addition to the parameters as a vector, we could also making our return value as a vector, right? We are returning a vector because vector double is a type, right? We could return double. We can of course return a vector of double. So what does this function mean? This function means given a v, a vector, we are collecting all the data that is between low and high, right? We are iterate through all the vectors, all the elements of vectors. If the element is in the range between low and high, we push back to our result vector. This is our result vector. And at the end, we return this result vector, right? So let's copy it. Writing another function called this. I need std. Right. So what we can do is we can, as you can see, it returns a vector. So when you call this function, you need to assign the output to a vector. So what we can do is we can define a new one called medium salaries equals to, this function is called between, let me move it down, equals to between of first argument, your salary, second argument, maybe a range, for example, the range between 0 and 10, right? You want to get a, it's a double. Let me change it to integer. Int. All right. So I need to get all the salaries that's medium between, for example, 0 and 10. Then what I'm expecting is 775 and 75, right? So that's my, that should be my output. So let me print it. When you print it, this is what they will give you, right? It basically means when it comes in, it will first iterate through all the elements. And if elements is in the range, you just push back their values, then return it, right? And what we can improve is instead of this, we could make it a constant reference. We don't want to change anything in your original salary, right? If we don't want to change your original salary and we don't want to waste the time copying your data, we could use a constant reference. It is exactly the same. As you can see, it's still outputting it, but it is making your program efficient. All right, so that's it. And let me go back. So your first exercise, how can we collect all the positions instead of all the values? That is between this range. How can we collect all these positions? Here is how we can collect all the values. How can we collect all the positions? Let me make it another function. Call it between position. All right. We want to return all the positions whose values are in this range. How can we do that? All we need to change is here, right? If the value is between low and high, instead of push back the value, we push back the index. In this way, we are collecting all the indexes, right? All the positions. Let's see how it works. Return all the positions. And when we run it, it'll give me the positions in here, right? First guy is 0. Second guy is 1, 2, 3, 4, 5, right? You collect all the indexes. Sounds good. Let's continue. So here's the solution, right? Instead of doing VI, we're just doing I. So that's easy. All right, so next exercise, how can we compare two vectors? How can we compare two vectors? It returns true if these two vectors are equal. It return false otherwise. Let me do that. We could, right, these are two of my input. First one is a vector, second one is another vector. Right? All of them are const. I don't want to change the values. I just want to compare whether these two numbers are, whether these two vectors are equal. How can we do that? First one, we can compare the size, right? If the size doesn't match, return false, right? If the size doesn't match, we know, of course, these two vectors doesn't equal to each other. If their size match, we need to iterate through all the positions, all the locations, right? Int I equal to 0, I less than a dot size. We need to iterate through all the locations and to see if there's any place AI doesn't match with BI. If it happens, it's a false, right? If nothing happens, it's a true. This is how we can compare two vectors. First, compare size. If size doesn't match, it's a false. If size match, but if any place AI not equal to BI, it's a false, right? And at the end, it's a true. So that is how we can compare two vectors. How we can use it. This is where we can use it. Right, assuming there's a series 1. Comment them out. We could see out, do they equal, right? Not A, series and series 1. Right, these two should equal because they are exactly the same. When we print, it will output a 1. I need a new line. Right, if at any location they doesn't match, we output a 0, right? Or if their size doesn't match, we output a 0, right? There are a few scenarios you need to consider, making sure all these scenarios are considered in your code. All right, so next I want to talk about something that's implemented in our STL. So when you search for the vector, so vectors are indeed implemented in the existing library, right? We are not implementing vector. So in addition to something that's similar to array, it also has many of the functions. We have already talked about like the pushback, right? Here are some functions that's already defined in the vector you could use, like the pushback, like the, where's the popback? Like the brackets, right? If you want to access each element, you need to use the brackets, or something like the size, right? If you want to get the size. It also has some other functions like insert one element at any location, not just the back. If you want to insert it at the back, just push back, right? You could insert into arbitrary location in your array, in your vector, or you could erase any position in your vector, right? They are all already defined in the library, so you could directly use them. But what I want to show you is, as an exercise, you need to understand how they are implemented. All right, so first one, let's consider removing an element. Given a vector and a position, I want to remove the position. I want to remove the element in the position. There are a few ways, right? I will show you the easiest way. If the order doesn't matter, I don't want to maintain the order. How we can do that is I just copy the last element into the ith position, then pop back, right? If I copy the ith position, the last position's element into the ith position, then pop back, it is indeed removing the ith element, right? But the order is not maintained. It's just removing one element. Let me show you how can maintain the order. If we want to maintain the order, it'll be slightly difficult, which requires many operations, right? If I want to remove element I just copy the next element to ith location, and I go on and on and on. Right? Let me show you how it works. If it's in here, all right. std factor. Let me make it a string, int, and yeah. So I have a factor v. As you can see, it's not a constant reference. It's just a reference. So you will be able to modify v. And then you have the position you want to erase, right? You have the position you want to erase. You just copy everything before you, after you copying it to the counter position. So instead of just showing that, let me print it out so that you can see what is happening. All right, let me show you this. Let me do erase this salary. Let me remove the position in 3. All right, so here is how we can call this function. And let me show you. As you can see, initially, it's too many. 1 and 5. Let me do 1, 2, 3, 4, 5, 6. All right, 3 is 0, 1, 2, 3. If I want to remove the element 4, what I did is I want to copy 5 to 4. This line, copy 5 to 4, right? Copy 5 to the location of 4. Next round, copy 6 to the position of 5. Then at the end, I want to pop back. And let me show you the final one. Print salaries. Right, as you can see, copy 5 to the location of 4, copy 6 to the location of 5, and then pop the final one. Using this case, I'm indeed deleting 4 as well as maintaining the order. Right, so this is the way we could maintain the order and remove the data inside your vector. This is also how it is implemented in your STL library. If you call .erase, it is doing similar things. So any questions on it? No? All right, exercise. How can we erase all the elements that is in the range low and high? How can we do that? If you want to think, right, it's really complex, right? Whenever you erase something, you need to copy it. Then you need to compare it. Yeah, so instead of thinking that way, you need to split your problem into smaller ones. I'm talking about the simplest thinking process, not the most efficient way to implement. But let me see, because we already have implemented the positions, right? We already have the positions. Let's do between positions. The salary, our range, for instance, I want to delete everything between 2 and 5. I will get the positions, right? First, I will get the positions by calling the function I have already write. Return the positions whose value is in the range 2 to 5. And then for each element in position, wait a minute, I less than position.size plus I. What I do is I want to erase this from my salaries. But there will be one tricky thing is whenever you erase it, the size will change. So your position will no longer be valid. See the idea? This is the thinking process. Wait. Assuming it's 1, 2, 3, 4, 5, right? Assuming you want to delete 2 to 5. So your position would becomes 2, 3, 4. No. 0, 1. No. It's 1, 2, 3. Your position is 1, 2, 3, right? So this position will get an array, keeping the index 1, 2, 3. These are the index for the values that's in the range between 2 and 5. Right? This is a function we have already implemented. And also, assuming you start from 0, right? Starting from the first guy, starting by deleting this 1. After you erase it, your new factor becomes size 4. Size 4. It becomes 1, 3, 4, 5. Now, if you want to delete the next position, it is no longer the same guy you are pointing to, right? Go back and think about this process. That's why instead of doing from beginning to the end, we go the reverse. Position dot size minus 1 greater equal 0 minus I. We will erase this position, and we will be able to see how it works. Let me delete this line, otherwise there will be too many print. Wait a minute. What am I doing wrong? Position. Not I. It should be position of I. Right? I am removing all the elements between 2 and 5 by combining, by using some existing functions we have write. So this is the idea about splitting your problem into smaller ones. You know, to implement this functionality, you know, you have to first get all the positions that's in the range, right? So you will first implement something like the between position. After you have the between position, you need to consider the how to erase them one by one, right? Then you need to implement something called erase. Assuming I just want to erase one position, right? This is the tedious way. Instead, you can do some other ways, like instead of doing them one by one, you can erase position at one round. But that will be, you guys can try it offline. So this is that. So insert are similar to remove, right? In order to remove, we copy them. And for the insert, it's the reverse. We copy them to the next position and then insert them into the position I. So here is exactly what we are doing. First one, we increase the size. We push back, increase the size. So now the last element in your vector are duplicated. Then you are copying them one by one to the next location. And finally, you will copy your value into the ith location. So it is exactly the reverse of your remove. If you guys can understand how remove works, you will be able to understand how insert works. So it is already implemented in STL. You guys can directly use their functions. This is just an exercise you can implement on your own. All right, so next, how about write a function that removes duplicate from a vector? How can we do that? Remove duplicate from a vector. What do we need? At least we need some function called erase, right? If we want to remove something, we need a function called erase. And also, we need a function that's showing you, okay, this guy is a duplicate, right? We need to remove this one. So by splitting this problem, what we could do is, or we already have the erase. So what we need is, how about a for loop that is from salaries position. So we say if it's a duplicate value inside your salaries, right? Of salaries I want to erase the position I. So here is my key logic. If the salary I is a duplicate value inside your salary, I want to erase this I. Assuming you have already implemented erase, right? So that one is, you are splitting your problem into smaller one. Next question is, how can we implement this kind of functions? Right, we could do something like the Boolean, right? This is the function we need to return a Boolean. And indeed, we can make it a constant, right? We are not trying to modify the vector v, and here is the value. So we say return true if value exists more than once in B, right? What that duplicate means, if the value exists more than once in your vector, it is a duplicate value. So what we can do is, we can count how many times does it exist in V, right? So what we can do is iterate through 0, I less than V dot size, plus I. If V of I exists your value, you will increment your count. At the end, we just return that's count greater than 1, right? If count is greater than 1, it means inside V, there are more than once exist a value. So this is how we can implement a duplicate function. Right? We are trying to making sure the problem becomes smaller and smaller. And as you can see, this is the comment I write before I writing the program, right? This is the thinking process. I want to return a function that the function returns true if a value exists more than once in my V. With this explanation, I start writing my program, right? This is how we can write it. Yeah, and if we run it, for instance, if I have 2 2s, 2 3s, let's see what will happen. Now I'm erasing all the duplicates, right? Because 2 and 3 are duplicates, I remove them, becomes 1, 2, 3, and 6. This is how we can remove the duplicates. Right. Any questions? No? How can we implement a bubble sorting of an array? What is bubble sorting? So let me show you what is bubble sort. So what is sorting? Sorting is kind of like assuming it's 3, 5, 1, 7, right? Your final goal would be 1, 3, 5, 7. How can you making sure your factor becomes this factor? It's called bubble sorting is one kind of sorting. It has many rounds. Round 1, it is scanning from the left to right. Scanning. Whenever it meets an element, it compare with its neighbor, with its next element. If they follow the order less than, nothing happens. If they don't follow the order, they exchange. So nothing happens, they exchange, right? And then compare, nothing happens. This is round 1. Next, scan it from beginning to the end again. Compare it. Doesn't follow the order, swap it. 1, 3, compare. 5, compare. 7, right? So you are basically doing many rounds. So in the naive way is making 4 rounds. If the size is 4, making it 4 rounds. So that's, if you search, you can find this kind of algorithm descriptions. So your question is, how can we implement this one, right? How can we implement this one? So again, making sure your problem becomes smaller, right? First, how many rounds, right? N rounds. Then in each round, we need a function that's doing 1 scanning. When inside 1 scanning, we are comparing element by element. And we need something that's swapping the values, right? So that are some basic things. Let me make it 3, 5, 1, 7. What we are trying to do is bubble sort of your salaries, then print your salaries, right? We haven't implemented bubble sort yet, but assuming bubble sort will change the order of elements inside your vector. So it means bubble sort will modify your vector. So it cannot be a constant reference. It's just a reference, right? Because it needs to change the order in your vector. So in here, we said it requires n rounds, right? So it indeed requires int I equal to 0, I less than vector dot size, this amount of round. And in each round, we said we need to scan from beginning to end. Okay, let's call it scan. Scan my vector. I haven't implemented scan yet, but I just assume each round it will making sure at least one swapping with its neighbor. All right, so that is called, let's make it a scan. By the way, it don't need to return anything. It's just a return void. All right, so we are done with this function, but we are also making sure our problem becomes smaller. How can we do scan, right? All right, let's making sure we can implement a scan. How can we implement a scan? Scan basically means scanning from left to right. So it's, let me just copy it. From beginning to end, right? From beginning to end. And we are comparing with neighbors. Whenever we scanning to one position, we are comparing the position with the next position. So we are trying to find out if vector of I is less than vector of I plus 1, right? We are comparing vector I and the vector I plus 1. Because there exists a I plus 1, you cannot go to vector dot size. It should be size minus 1. Otherwise, you will go outside your range, right? So you are comparing it. If this one happens, it means the order is good, right? You are expecting it to follow this order. The previous one is less than the next one. So what you should write is if it's greater than, if it violated this order, what should we do? What should we do is a swap, right? Let's call it a vector swap. We are trying to swap vector, the position I with I plus 1. Then we are done. Assuming we have this kind of function called a vector swap, swapping the location in I and I plus 1, we are done, right? Just swap scanning from the beginning to the end, comparing it with previous with the next one. If they violate the order, swap them. So we are done. All right, we are making sure the problem becomes even smaller. So now our next problem becomes, how can we do a vector swap, right? Assuming we have a vector int position 1, int position 2. How can we do a swap? It's basically swapping 2 variables, exactly the same. We have learned that creating a temp, right? That one will keep one of the position. Let me keep a position 1. Then copy position 2 to position 1. Then restoring the, wait, is this? Yeah, to temp, right? This is something we already learned, how to swapping two values, two variables, quite easy. So we have done swap, we have done scanning, we have done this. Wait, why there's a error saying no variable conversion from blah, blah, blah to int. Let me see. Int here comes in, int here, it's a dupe. Wait a minute, it's a bub. Wait, why there's another dupe? It's called a scan. Sorry, I forgot to modify the name. All right, if we have a swapping, then we can implement a scan. If we have a scan, we can make an end round of scan, right? Then we are done. Let's see how it works. Yeah, it works, right? Or what we can do is after each scanning, we could print. Let me print the initial one. Print of our factor. When you run it, right, as you can see, the first line is the initial one, 3517. And in our first scanning, we find out 5 and 1 violates. Then we swap, right? Becomes 3157. In the next round of scanning, we find out 3 and 1 violates. Then we swap, then 1357, right? And for the remaining ones, indeed, they are not necessary. But anyway, let's make it one more scanning. It doesn't matter. So that is how we can implement bubble sorting. The reason I introduced this one is helping you to train your mindset, right? Splitting your problem into smaller ones, smaller ones, smaller ones, smaller one, until someone as easy as a swap, right? A swap is quite easy. The reason we introduce functions is helping you to train your mind to become modularized way, right? Everything is modularized. Think of every problem as modularized. All right, next we are going to talk about the two-dimensional arrays or double-dimensional vectors. So we said if it's a factor of int, right? Factor of int, we are allocating continuous memory for integers. Every element is int. Every element is int, right? If it's a factor of int, and we said factor of int is a type, right? This one specifies the location, the space you need. So the first element of fact is a factor of int. This is the first element. Second element, factor of int. Right? Go on and on. So if you guys see this one, it means 1, 2, 3 is in here. 4, 5, 6 is in here. Each of them are just one factor. And if you look at this factor, you know they're also occupying space in this way. So it's also int, int, and int, right? So 1, 2, 3, 4, 5, 6. The space will be like this. It's a factor of factor int, right? It's a factor of factor int. Each factor int, a bunch of int. So in this way, we can call it two-dimensional array, or if the size are exactly the same, it becomes a matrix. Because you guys haven't learned linear algebra yet, let's just call it a factor anyway. So as you can see, we only say the second type, the element, each element is a factor. We then specify the size, right? So they don't have to follow exact size. It could be 3 elements, then 1 element, then an empty factor, then 3 elements, right? It's totally valid. We only says each element is a factor of int. So their size could be different. Their size could be different. When you learn arrays, you know they have to follow the same size. But in here, they can be different. And here are a few ways to initialize a vector, similar to our way of initializing a vector, right? Let me copy it here. Just give it some real name. All right, so we have learned this kind of notations, right? Initialize a vector with size 3. It's creating a vector size 3. And it with another one, it says create 3 vectors. Each vector is size 3, right? Now it becomes a 2-dimensional vectors. And what we need to learn is how can we print it? That's always the first one we need to learn. Let's say print, let's call it a print matrix, which is print a 2-dimensional array. How can we do that? Again, this one becomes a type, right? This one is a type. We put a reference so that we can save space. We don't need to copy them. And we can put a constant such that we will not modify the data. So what we can do is for int I equals to 0, I less than factor dot size plus I. Right. So for now, we have the factor of I. Typically, we just see out the factor of I, right? But instead of doing that, because factor of I is now a factor of int, it's no longer just int. So the ith element of factor is now a factor, right? And how can we print it? We could create another one called j less than factor ith size. Because factor I is now a factor, you can call a size. It will give you the size of factor I. Now you can see out. Because now you have the factor of I, which is the ith factor of the 2-dimensional array, and then the jth element of that factor. Right? You could see out that separated by a tab key. After every line, you could see out a new line, right? So the inner loop is print every row. The outside loop is loop around the rows. We typically writing a 2-dimensional array for 2-dimensional factors. No, it's a nested array, a nested for a 2-dimensional arrays, right? Like the first 4 iterated through the rows, second 4 iterated through the columns. So here's what you can do, and you can print it. For example, all of them becomes 0. Then we can print matrix of your factor, right? As you can see, it prints out the content, right? It also becomes 3 by 4. So it becomes 3 rows and 4 columns, right? 3 rows and 4 columns. This is how we can print a 2-dimensional array. So any questions on it? Any confusions? Because it's very important here, if a factor is a 2-dimensional array, factor of I is a 1-dimensional array, right? It means the 1-dimensional array then get the jth element of your 1-dimensional array. So this is how we can access one element. And yeah, that's the case. So we said we can access a vector using a for loop. That's typically what I do. And also, in the future, when we learn containers, we could also iterate through a vector using this way for a double element, comma, v. It means iterate through all the elements. So the first round, element equals 8.1, second round element equals 9.2, last round element equals 1.0. It is indeed exactly the same way of iterating through a list in Python. So this doesn't exist in the old C language. It's new in C++. And we said programming languages tend to learn from each other, right? These are something we learned, C++ learned from other languages, so that make the notations simpler, right? Instead of doing this over and over again, you can also write it in this way. But I typically prefer writing my code in the first way. It's the old way, and it's very flexible. I can do many things with it. But if you want to learn this, it's also fine, because it will be used in the second semester of your class. You could also try that. You could also try this, right? If it's a double dimensional array, you could say, for each element, in here, each element is one dimensional array. And you can iterate through all of them, then print them, right? Very convenient ways of accessing each element instead of the index. But I will not talk too much about it. If you guys are interested, play with it. What I want to tell you is something that might help you with your homework. Because last class, people tell me that they didn't learn linear algebra, so they don't know how to compute the product of two matrices. So let me change this problem. Change to a problem that will be similar to our homework, which is the magic square. What is magic square? Magic square thing, some numbers, right? Any number, I just randomly fill in. What you need to make sure is every row. For example, if it's 3 by 3, it's 15. Every column is 15, right? That is called the magic square. When you sum up, when you sum up, they're always equal. So it's called a magic square. All right, so in this magic square, there's one algorithm that can help you quickly fill out the magic square. What is the step? First one, find out the middle point for the first row, fill in 1, goes up and left, this direction, goes diagonal. If it's outside, wrap it down, wrap it right in here. Here is 2. Goes up. If it goes outside, wrap it. Continue. If you hit someone, goes down. Then goes up, goes up, goes up. Hit this guy, goes down. 7, goes up. 8, goes up. 9. This is one valid solution. You could rotate, transpose, anyway. So this is one way. So how can we implement this? Assuming you already know this algorithm, how can we implement this? As you can see, basically I'm filling 1, 2, 3, 4 until 9, right? There's no jump in the middle. So I just fill in 9 numbers. The question is, where should I put my number, right? Assuming I know the previous location, assuming I know the location of this guy, row and column. What is my next location? Goes up, right? So what it means is row -1 and a column -1, right? This is the next location. I just keep doing that. But as you can see, we need an if statement. We go and check if this guy is already occupied. If it's occupied, it goes down, right? What is goes down? It basically means row +1, right? So we need to implement an if statement saying, checking if the location is already occupied. If it's occupied, we do this strategy, right? If it's not, we do this strategy. And we also need to take care of the wrap, right? If it's a wrap to the left, for example, it becomes -1. Starting from 0 becomes -1. It becomes n-1, right? So it's a wrap up. we need to deal with the wrap up, checking whether the location is already occupied, and then doing that. So let me implement this. Assuming initially it's 3 by 3, I will fill in all the locations with -1, so that we will be able to see if this location is already occupied. Right. All right, let's call it a magic. Let's magically fill in these locations. Then print it. Print your matrix. Right. So now we need to implement a function called magic so that we can magically put in the numbers of a two-dimensional arrays. Right. It's a reference so that we can fill in numbers. And we said it's indeed quite easy, right? We start from 1 until, let me keep the size, int n, let n be the size, vector.size. We start from 1 until n times n, plus I, right? We just fill in the location, some row, some column, assign it to I. Then I will give the initial row and the initial column. Then I need to update my row and my column, right? Assuming I have implemented every functions, I will start from my initial position, which is the first row and the middle column. My middle column is n divided by 2. So we will fill in 1, right? Then update my row and column, fill in 2, update my row and column, update 3, right? Fill in column. We do this. So now my complex problem becomes, how can we update this index, this position, right? Row and column, how can we update them? And in order to do that, indeed, we need information about a factor, right? Whether this position is already occupied or not. We need the information. So what we can do is, we could have this one as our parameter. Then we could have our row as parameter and the column as our parameter, right? Row minus minus, column minus minus, right? That's what we are trying to implement. So what's the problem? First, the problem is whenever you modify row, it's not modifying the row in here, right? If you are trying to modify a row in here, it doesn't modify a row in here. So it has to be a reference, right? So that whenever you update your row and a column in your, it's no longer magic function, it's called update. In your update function, whenever it's modify row and a column, it will be reflected in the magic function, right? Making sure it's a reference. And we say in here, minus minus will go to the -1. What we can do is, okay, if row is less than 0, row plus equal n. We haven't defined n. Let me define n. Vector dot size. Right, we do row minus minus. We go left. If it becomes -1, we plus n. Similarly, in here, if column is negative, we plus n. So that making sure we can wrap up, right? It's not going to the negative index. So we are basically jumping to the diagonal. And next, we want to verify, is this position already occupied? Is this position already occupied? What does it mean? How can we write it? How can we write it so that we can making sure it's not occupied or occupied? How can we? Yeah. Yes. Remember, we initialize our vector with a -1. And we fill in from 1 to n squared. So if it's still -1, means it's available, right? We could put our next position. We could put our next number there. But if it's not a -1, it means it's already occupied, right? If it's already occupied, how can we update? Goes down, right? Goes down a little bit. But remember, we have already modified our row and column. We need someone to remember the original row and the original column, right? And if we know the original row and original column, which means we go back, then goes down. Goes down means our new row becomes row +1. Right? It means goes down. Right? Let's see if it works. Still, there are some -1. Right? How about the column? We forget to reinitialize the column because the column is negative minus minus. It already changed the column. We haven't recovered the column. We need to recover the original column. So sometimes you need to do this kind of debugging, right? It's, oh, wait a minute, it's not row. It's the original row +1, right? We go back to the original position, goes down 1 position. Still -1, right? Yeah, you need to do more debugging. Let me see. Here, common errors you might happen, right? If it's less than, it means it will not fill in number 9. When it fill in 8, it finishes, right? It should be equal. So here are some of the common things you might have in your programming. Now it becomes correct. You can verify it. And you can also change it. For example, let the size to be 7. 7 and 7, right? We could also do it. It will output a magic square, right? This is the magic square it outputs. All right, let me ask you, is this one correct or not? How can we verify? How can we verify this number is correct? This printed matrix is correct. We could write another function called verify, right? Okay, verify. We compute every row and every column and to see if they matches the number. So let me implement this one. Let me call it verify. All right, if I want to verify, first, again, I need the size n. I need the size n. What is the sum of every row? How can we compute that? So what's the sum of the total number? So the sum should be 1 until n squared, right? First element, last element times n divided by 2. These are the whole sum. And for every row, it should be the sum divided by n. So it should be this, right? You are checking, then your next step is sum every row, then sum every column to see if they matches the sum, right? So what you can do is, okay, we call it expected sum, right? Then we do row by row. First, check row by row. Factor size plus I. Oh, wait a minute, equal to 0. I less than factor size. Then in here we compute the sum. right? First we get a sum equal to 0. Then for int j equal to 0, j less than factor of I, it's a factor, the size plus j, right? Sum plus equal factor of ij. This is the sum for every row. For every row, right? Expected sum is the number we're expecting. Then we are comparing if expected sum doesn't match with the sum of each row, we could see out something. See out row I does not match, right? And at the end, we could see out rows done. Let's just check the rows. We're basically computing the sum of each row, compare it with the expected sum. Then if it doesn't match, we output, right? If we run it, every row doesn't match, right? Row 1 doesn't match. Yeah, yeah. So we have some issues in here, right? This one doesn't match, right? Yeah. Times n. Because first element plus last element times the number of element and times n, right? Then divided by n. Then divided by n. This is the expected sum. All right. So just checking if you guys are sleeping or not. So this one is indeed quite easy. As you can see, rows are done. We have verified all the rows. You can also do similar for the columns. And indeed, you can do, as long as this n is an odd number, it can work. Either it's 17 or not, right? It could be any large number. You can see rows are done. Wait, I didn't change this. N and n, right? It can be any number that's odd. Then we can verify it's correct, right? How can we do the columns? How can we do the columns? Check all the columns. How can we check all the columns? Yeah. The only thing we need to change is change here and here, right? This guy becomes J. This guy becomes I. And let me use N here so that it's easy to see. Right. Here should be J. Here should be J, I, and I. Now becomes column J does not match, right? So what we did is instead of for I, now we start with for J. J is the column index. For each column, column 0, we iterate through all the rows, right? If J is 0, then we becomes row 0, column 0, row 1, column 0, row 2, column 0, right? We are doing the summing of all the items in the first row, first column, right? So we can do that, and you will be able to see it's also passed, right? It should say columns down anyway. So yeah, that is what we can do. Any questions on it? It's about two-dimensional arrays, right? How you can access them through I, through J, it doesn't matter. You can change the order. just in case you guys are curious about this problem, someone asked me after class. So this one is about multiplying two-dimensional arrays. For example, this is our 3 by 5, and here is a 5 by 2. What this one is asking you to implement is computing this row and this column element by element, compute them, multiply them. Your output is a 3 by 2 matrix. The first element is the first row with the first column. First row of left with the first column of the right. Wait a minute, it's 2 by 2, so this one should be larger. It is 2 by 3, all right? The first element, the row by the first column. Second element, the first row by the second element. It's really complex, right? If I give you 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The first element is 1 square plus 2 square until 5 square. The second element, assume it's 1, 1, 1, 1, 1. It is 1 plus 2 plus 3 plus 4 plus 5. How can we implement this? How can we implement this? For each element, if it's row and the column, it is this row times this column, all right? You're basically asking, finding a row in here, finding a column in here, getting the output, assuming these two numbers exactly match, right? Computing them one by one. It indeed requires 3 for loops. I, J, K. For I, each row. For J, each column. For K, each element, element-wise computing. So this one is more complex. If you guys are interested, try to implement this one. All right, so any questions so far? No? Any questions about our, yeah, by the way, let me show you this one. Let me show you this one and finish this class. So for a vector, let me do a vector in here, vector of int of your salaries, 1, 2, 3, 4, right? What we can do is iterate through the size of salaries like this. You could see out salaries element. Just a tab. At the end, I see out a new line, right? What we can do is like this. Let me comment them out. Just define a vector, and we use the index. We use the index to iterate through all the elements. For the next part is for let it be double, so that you guys can distinguish between element and index. Here, let me put an element here. So this line and this for loop and this for loop are exactly the same. These two for loops. The first for loop using index to iterate through all the elements. For the second for loop, for the second for loop, it's iterating through the real element, the values, instead of the index, right? So it's indeed what it's doing is the first round element, you are defining a new variable called element equals to salaries 0. Second round, element equals to salaries 1. Next, salaries becomes element becomes salary 2. So it's value copying instead of accessing the data. What you can also do is you can reference to it. No problem, right? It becomes a double reference element pointing to one of the locations, right? It becomes a pointer. It becomes a reference. Or you can put a constant. If you don't want to change the value, you could put a const, right? It's a reference to someone. The reason we introduce this is if it's a two-dimensional array, for example, this guy, if it's this guy, right, what we can do is we can iterate through the double-dimensional array, but the type doesn't match, right? The type is factor of int. The type is factor of int. Type is a factor of int. And what it does is it's actually creating a reference called element that is pointing to the first element of your two-dimensional array. You're iterating through each value, right? Instead of iterating through the index. And what you can do more is you can continue to, for instance, int the e inside your element. Because now your element is a vector, you could also use this notation and you could output e. Two-dimensional arrays, right? First one, I use the type of each element in the two-dimensional array, which is a factor of int. Second one is the type. Int is the type of your factor int, right? The reason I use the reference is because factor copying is time consuming. That's why I use a reference. Second part is because an integer copy is efficient, so I don't need a reference. And also, because as you can see, writing this part is quite complex, right? C++ also provides you with something called auto. Compiler will help you figure out what is the type of element. Compiler will help you do that. We just put auto here. So as you can see, our languages are helping the programmers, right, doing efficient things. And if you read the newest code, especially written by someone, if you read the GitHub, you will see many places people using auto. The reason they use auto is because they don't want to type these long things. It's just one, right? If in the future their part is some other data structures, it's very complex. It'll be very, very long. And people try to avoid that using auto. So ask the people to automatically guess what should be the type, right? You could also put auto here. Ask the compiler, guess it. What's the type, right? I don't want to tell you, you just guess it. It's auto. So if there's no confusion, compiler will help you with that. And this is this part. And we will cover this in the second half of the semester. But if you want to use it now, it's also fine. Right? It's very convenient. It's very useful. Because you know, typing down, where is it? Typing down this kind of for, right? Int I equal to 0, I less than n, I plus plus. It's very tedious. You guys can do simpler ways. All right, so any questions on it about the new grammar? Yes? Okay, const is because now, let me see if I can copy it. For now, this element is a is a reference, right? If I don't do this const, I will be able to modify the vector. So I can say element 1 equals to 0. By the way, it's a two-dimensional array. Let's make it 100. Not an array. Oh, this guy is an array. So let me do 1 becomes array, right? Let me remove this one and print my matrix vector. Erase this part. So as you can see, initially all of them are -1, right? Initially all of them are -1. Then I iterate through all the elements inside my two-dimensional array. Because it's a reference, if I change 1, you will be able to see what's happening. It's too much. It's too much. Let it be 3 by 3. See the new line not needed. Right? If it's 3 by 3, as you can see, because it's a reference, these elements are first round pointing to the first row. Then if I modify the second element to be 100, the first row is modified. Second iteration, it will pointing to the second row, modify the second element. Next round, modify the second element, right? If you are using reference only, you will be able to modify it. And the programmers sometimes prefer, if you don't want to modify something, put a const, just in case you accidentally modify something. All right. Any more questions? It's exactly the same as defining a new variable. It's a reference variable pointing to the each element of your vector. All right, vector 0, vector 1, vector 2.